5, we're going to take a look at finding angle A. And we've been given two other measurements. One is on the side here, 4 and then 14. And so the first thing I need to recognize is if I am going to end up using sine or cosine or tangent, and that's dependent on the measurements that I actually have. So when I'm looking at angle A, I've got to determine, do I have the opposite side, the hypotenuse, or the adjacent? And in this case, I've got the opposite side here, which is 14. Hypotenuse is over here. I don't know that one, but I do have 4, which is the adjacent side. Okay, so together the opposite and adjacent is part of TOA, tangent. So I'm going to use the tangent of angle A. So I'm going to write this out to say the tangent of A equals that ratio here, and it's going to be the opposite over the adjacent. Opposite over adjacent. The opposite in this case we said was 14, and the adjacent is 4. So what this is saying is the tangent ratio of whatever that angle is, whether it's 23 degrees or 94 degrees or whatever, the tangent ratio is 14/4. But we're actually looking for what this degree measurement is. So I don't want to I don't want to have the tangent of A, I want just A by itself. So to get A by itself, I'm going to undo the tangent of A by taking the inverse tangent. Okay, the inverse tangent of A is going to get me A all by itself. But if I do that on one side, I've got to do that on the other side. I need to take the inverse tangent of 14/4. And that's something I'm going to need to plug into my calculator. So make sure that you are on degree mode in your calculator, and then use the arc tangent of 14/4. When I did that, I got just over 74 degrees. I'm going to round to the nearest degree here. And I know that this must be a 74 degree angle because that's the only kind of angle that has a tangent ratio of 14/4.